The last law here is the law of logarithms for roots, which is basically just the same as the law of logarithms for powers. And it states that if you have a log of x to the nth root, base a, you can rewrite that as 1 over n, so whatever root we have, times the log of x base a. And you might already see why, you might not, but let's do an example first to illustrate. In our example, we have the log of the third root of 8, base 2. We could take the third root of 8 and get 2 and solve this pretty directly, but let's actually apply the law of logarithms for roots. The law of logarithms for roots says that if we have the third root of 8, we can rewrite this as 1 over the root, so 3, times the log of 8 base 2. What's the log of 8 base 2, or what exponent do we have to raise 2 to get 8? The answer is 3. So if we have 1/3 times 3, a third of 3 is 1. So we've now solved that by using the law of logarithms for roots. How is this similar to the power rule for logarithms? Well, if we rewrote this as a log of 8 to the exponent 1/3 base 2, we've taken our root and written it as a fractional exponent, which in the exponential functions unit in grade 11, we talked about how those two were similar statements. So what could we do if this has a power now? Well, we would take the exponent on the power and bring it in front of the logarithm and write it as 1/3 log of 8 base 2. And now we basically just use the power rule to do the same thing that we did in the roots rule for logarithms example. And we could finish this by evaluating the log of 8 base 2 is 3, because 2 to the exponent 3 is 8, and a third times 3 is 1. So very similarly to the law of logarithms for powers, we have the law of logarithms for roots. Conditions, same thing. X, y, and a must be greater than 0, and a cannot equal 1. In terms of the proof, it's actually quite similar to the power proof, but let's do it as well. I'm going to look at my right side where I have the log of x base a, and I'm going to rewrite that, or I'm going to let it log x base a equal m, using m again. Rewriting that as a power, we get a to the exponent m equals x. On our left side, though, we have the nth root of x. So if I want to get that, I would need to take the nth root of a to the exponent m. And the nth root of a to the exponent m would be a to the exponent m over n. On our left side, we actually have an expression for the log of the nth root of x base a, and we just wrote what that expression is equivalent to. It's equivalent to a to the exponent m over n. So I'm going to, instead of writing the nth root of x, I'm going to write a to the exponent m over n, and a to the exponent m over n inside a logarithm with the same base. We can use our common property and just write it as m over n. What's m? Well, we defined it earlier. It was the log of x base a, so I'm going to make that replacement. Log of x base a, and then we still have to divide by n. Instead of dividing by n, I'm going to write it as 1 over n in front of the logarithm. So there we've demonstrated the law of logarithms for roots.